Hello, everyone. It's Michael McClellan here, Levine Electronics and Electric. Thank you so much for joining us for another lunchtime COVID webinar. Perhaps we will return to life as normal, whatever that looks like, very soon. We are very lucky today to have with us who volunteered to perform this presentation and is not even responsible for our geographical area. So she's taking a lot of time out of her day to educate us and our customer base on the application of Danfoss drives in solar pumping applications. A couple housekeeping items right before we get started. This is a webcast. Unfortunately, today I don't have the ability to unmute your phones. So for some of you who hate the sound of your own voice, this is a welcome and pleasant news. For others of you, I am sorry. But we would love it if you would type in your question as you think of it into the question box, and John or I or Lise will answer your question. And John, Lise has requested for you to prompt her as soon as a question comes in. She wants to clarify things as she goes, and then I'm sure there'll be a few questions at the end of the presentation. So without further ado, here is Lise Houston.
Thank you, John. Bob and everybody else that's on. I saw Bob Darby's on, and Mike, thank you. As he said, my name is Lisa Houston. I am based out of Arizona now. I used to be in Southern California, and now I'm in the Phoenix area. I'm responsible for Utah, Arizona, Southern California as a regional manager for Danfoss, but I also have business development roles in energy and electrification, which includes solar, energy storage, power conversion, other applications like that. I'm also responsible for the mining vertical business development throughout the West, and also marine. So those vertical segments of energy, marine, and mining go beyond my regular territory to cover the entire Western US. And the reason why I was asked to do this particular presentation is because I've had some experience in selling and working with customers that have purchased or have wanted to purchase our Vacon solar pumping drives. And so it's kind of a little niche product. It's a little niche market. And I've gone through the struggles of getting this product out there. So that's why I offered to help. So I'm very excited to share with you about this. So let's get going and let's just start talking about it. So basically what we call solar pump is when you've got the pump running on electricity that is generated by a PV array. And obviously the benefits for that is it's ideal for remote locations where you may not have a grid supply available. You don't have to use a generator to run it, which is a fuel powered generator. It is continues to operate during the day uninterrupted if you're using PV arrays, and it is of course considered a green or a clean energy and good for the environment. Some interruptions obviously that could occur would be rain, but it's the point they were making here was you wouldn't be interrupted by grid downtimes. So some areas, especially in parts of the world where utility power is not consistent, this becomes a big deal. So in many cases, some governments are subsidizing fuel-powered generators to solar systems. That really isn't the case here in the US. I haven't encountered anything like that, and I've had people deeply look into it. But this is a PowerPoint that is used globally, so it is true that in some countries they do have that, but I haven't seen it here. So obviously water is very critical and important for growing food and other things. And the idea behind the solar pumping was to help reduce poverty and economic growth in remote areas. Now, again, some of this may not apply to us here in the US. We don't have such dramatic poverty and lack of utility power and stuff in remote areas. But again, this is supposed to be a presentation for the globe, and there are areas around the world where they are, where those situations do exist. So typical areas of use is agriculture, obviously, for irrigation, some rural community drinking water, or sanitation water, animal farming, livestock breeding, etc. I will add here from the units that I have sold, they have been bought, several have been bought by large ranchers. And the ranchers that have used this, like in California and stuff like that, they just wanted to have the ability to fill their storage tanks during the day for free using solar panels. And they may have a ranch with just animals. One was a citrus rancher, had a ranch with citrus trees on it. And they just, in the past, had always been using a generator to run a pump to fill their storage tanks. And now they use the PV array. The PV array actually doubles as a shade structure for the animals as well. And so that's just one example beyond these here. So here's a picture of an IP20 drive. This is not our brand. And I've actually did replace one like this out in the field, where they had an IP20 drive built into a cabinet with switches and everything needed to protect the drive out in the elements. And because it's out, you have exposed to the sun and environment, you had to have adequate cooling, and you would end up with problems. And that's why I ended up selling one of ours to replace another brand. I think it was a Mitsubishi, if I remember right, that was in a cabinet because it kept failing. So this is just an example of, you know, how a competitor would do in a solar drive versus what we're offering with our NEMA 4X outdoor rated or IP66 outdoor rated drive. So that's what we're going to compare it against, our IP66 drive. So with an IP66 drive, you do not need that cabinet. You do not need to worry about cooling fans. You don't have to worry about, if I go back, hold on. You know, you can see in that cabinet that there are also, you know, they've had brought out some terminals and some other things that would not be needed in a IP66 drive. So our IP66 drive, I'm going to call it the Vacon 20X or the Vacon 100X. And we're going to go into more details of the specifics of those drives. But just in general, they're outdoor rated drives that can be installed without a cabinet. They come with a special application software with a algorithm integrated in the drive for solar. That algorithm is called, we call it MPPT. And if you're in the solar industry, that is a familiar acronym. It stands for Maximum Power Point Tracking. And we actually put the 4 there to indicate that we have 4 algorithms that are running simultaneously in our maximum power point tracking software that gives you the best power generation or the best response to the solar situation that you're in to get the maximum power out to the drive. And we'll talk more about that as we go along. All water treatment functionalities are available as for the standard Vacon drive. What they mean there is your PID loops, all of your other features that you would expect in a pump drive software remain in the drive even with the solar software. So the benefits of a IP66 drive, of course, would be your standalone feature or standalone fully tested drive right out of the box. It's compact and maintenance free, no air filters to replace or clean. You don't have to worry about a cooling fan in the cabinet failing. On the smaller drives, we don't have any cooling fans. Some of the larger ones, we do have cooling fans, but the drive will continue to operate even if the fan were to fail, unless it got overheated. So that gives you time to replace the fan if you had an issue. We have a Gore vent in our NEMA 4X drives. What a Gore vent is it's a vent that is plugged. However, it breathes. So it's a vent that can expand and contract so that the drive breathes in order for to maintain constant pressure within the drive with the outside environment. So it helps protect against moisture and condensation developing in the drive as throughout the day, as the temperature changes, as the moisture outside of the drive changes in humid areas, for example. This vent is a big plus against moisture and condensation developing. So you don't need a heater inside the drive. So on that cabinet drive that we were looking at before, depending on the environment that you're mounting it in, could possibly require you add a heater to that enclosure in order to prevent condensation occurring. You can get a main switch, a surge protection and fuses can be placed together in a string box in a smaller sealed cabinet that does not require additional cooling. So if you look at that picture there, you see the solar panel, and then you see the main switch there on the in that box. You can see the little red button. Now with our NEMA 4X drives, you can get a main switch on the drive, but you cannot get inside the drive the fusing and the surge protection. And we're also going to talk about a diode to prevent backflow of current that could damage equipment. And all those things could be housed in a smaller NEMA 4X enclosure out in the environment without additional cooling required because they're not heat generating devices such as an inverter. Okay, dual supply mode, power blending. So dual supply mode is something that would be used when you need full water flow, even when the sun isn't shining at full strength. So at nighttime, or if you have rain or cloud cover during the day, and you require that you always have pumping going on, you can do a dual supply mode. That means that the AC from the mains is used when there's not enough DC voltage available from the solar panels. Now, Danfoss solar pump drives are industrial drives and can be supplied normally from the grid as standard. So there are two ways of doing this. You can use a switchover switch with delay from AC to DC, and you can do a dual supply AC and DC connected to the drive continuously at the same time. However, in dual supply, you must take care of safety situations in case of the drive rectifier fault or the AC supply power is down. If that occurs, it's possible that dangerous DC voltage from the solar panels will travel as far as galvanically possible. That basically means as far as current can flow, it will flow. So we have to practice or work to prevent that. And that would be done by the integrator, by the system supplier. And we will, we can give some guidance and support on that. There's an easy and safe and reliable way to do this if you're doing the changeover switch. And when AC and DC are always separated and one is disconnected when the other is connected, it is not possible to have the dangerous voltage coming out. So you put a delay between the switchover to wait that the drive voltage drops from low enough from the one source before you switch to the other source. So as you can see there in the picture, we have the solar panel contributing, and we have the grid supply also supplying to the inverter, and there's a changeover switch in there. And that includes other components that will make sure that the other supply has been fully disconnected, the drive has been fully discharged, and then it will switch in the other source. So there is a delay there. It could be okay. For example, the rancher that I was working with and the applications I've been working with early on, this was acceptable. They simply would just switch over. I had one guy that actually did it manually. Whenever he needed more water, because maybe there was 5-6 days of pumping of gray skies and he wasn't able to pump enough into his tank, he would literally just go down and he would manually switch it to the grid power to fill up the tank as needed, and then he would switch it back, and the delay was nothing. It was irrelevant to him. I've got an OEM that is doing some of these systems now where they do not want to have any delay, and they want it to be a seamless blending of the two powers, and they do it this way instead. So it's where you're actually blending the two power supplies together, and that's because you do not want an uninterrupted flow, and which you would get with the changeover switch. But there's some things you have to be very careful about doing this. So in this case, you have the AC and the DC supply, the AC from the solar panels, the supply from the grid connected at the same time. You need a device in there that will be monitoring the AC supply in case the mains goes down. So what you can do is you could put a blocking diode in to protect the solar panel from getting any excess voltage that might come back from the grid to the solar panels. Is one way to protect the solar panels. You will note that we also recommend, or you will see it later, a diode as well to protect the solar panel from just any other situation that can occur where it would back drive current into the solar panels. So there are explicit instructions in the manual. You see my note there. In the manual, it will actually specifically say, do not connect AC and DC at the same time. it only offers in the manual the first solution that I just described with the changeover switch with the delay in between. And that is because it is the safest way to do it. And our 100X UL approval is based upon that comment and on that instruction from our manual. So what I'm telling you here that can be done is outside of the manual. It's something that the system integrator or the panel builder, whoever is working on this system, is taking the responsibility for all the safety involved if they choose to have the solar panel and the grid connected together. We have an application note that I had created to help explain the safety involved in doing that. And technically, the UL is not valid when it's done this way, but in many cases, the customer doesn't care about losing that official UL rating. Although the drive will still be shipped with the UL label because we're assuming it's being installed per the manual. So that's just a word of warning that you can do this, your integrator can do this, but it's with caution and with the understanding that Danfoss does not document that or promote it that way. Okay, so let's talk, so that's kind of just a little bit of the background of what solar pumping is in the environment. But now let's talk about the products, and then I'm going to go into the details of the software a little bit of how it does it. And then after that, I'll go in the details of how you order it and things like that. So we have three drive products that can have the solar software installed in the drive. So the Vacon 20X, it is available up to solar panels up to 800 volts, and it's up to 10 horsepower. It has a maximum ambient temperature rating of 50 degrees C. In this case, with some derating. So we have some derating information that we can provide to you in our manuals that explains that the drive is fully rated for 100% of its current rating at 40 degrees C, and then you need to derate it if you feel that or know that it will be in an environment that can reach up to 50 degrees. And I think it's like 15% derate or current derate or something like that, but you can look it up. And then we have the Vacon 100 and 100X. In that case, those products can have a temperature up to 50 degrees C or 60 degrees C for the 100X. So 50 degrees C maximum ambient for the 100 and 60 degrees C for the 100X. The X on both the 20X and the 100X indicates it's an IP66 outdoor rated drive. The 100 without the X is a NEMA 1 or a chassis IP20 drive. That's the one that's only rated to 50 ambient. The X is rated up to 60 degrees ambient. And again, we must do derating. Once you get above 40 degrees, we have to start doing some derating. But still, 60 degrees ambient has made this drive, the 100X, successful in the Arizona desert, in the California desert, throughout the Texas desert, Oklahoma desert, etc. And actually, it's works down to minus, both the 20X and the 100X work down to minus 20 C. The 100X has a optional heater that accessory that can take it down to minus 40. But solar pumping typically isn't installed in environments where the wintertime, the cold is that cold. So on the 100, you can go up to 1,000 horsepower. In the 100X, you can go up to 50 horsepower. So you will see that as we go along here. So on the 20X, you will see that we have an AC supply rating of 380 to 480 and the DC supply, which is the PV array, up to 800 volts, up to 10 horsepower. In the 3-phase 230 volt, your DC supply or your PV array can be up to 400 volts DC, and that is available to 5 horsepower. And then in a single phase 230 volt part number or unit, it's up to 2 horsepower, 400 volt DC. So these drives have large capacitor banks for its category, so the sudden changes in solar power availability during operation are smoothed out and avoid annoying trips. The 20X has a high 2G vibration rating that may or may not be applicable in your environment. But there are some times where the drive is mounted on something that's vibrating, maybe from the pump motor itself is causing vibration that is transferred to whatever the 20X is mounted on, or you may have the 20X mounted directly on the motor. We've had customers that would fashion their own motor mounting plates to put the 20X on the motor. So 2G is larger than most drives on the market. Most drives on the market can be anywhere from only a half a G to 1. I think I've seen most was 1.5 G. So it can handle vibration. 50 degrees maximum ambient temperature. The maximum power point tracking software is included in the solar software. It's a 4-algorithm control scheme to obtain maximum power for any environmental conditions. So it basically extracts out or takes from the solar panel and uses those algorithms to give the maximum out to the motor. On the 100X, we have up to 50 horsepower in a drive that is a 380 to 500 volt AC supply, up to 800 volts DC from the PV array. And at the 230 volt, which is a 400 volt PV array, up to 20 horsepower. So the 100X has some additional features that the 20X does not. The 20X has a very basic keypad with just some numeric codes and indicators. It's typical for a micro drive, if you're familiar with that, where it would just say P01 to tell you that you're looking at parameter 1. It's not detailed, whereas the 100X is a full English language alphanumeric display where everything is in full words. So it's much more user-friendly and intuitive. So for the customers that I have worked with so far, in all honesty, everybody has bought the 100X and no one has bought the 20X. A lot of it is because when these are out in the field, in the middle of nowhere, they appreciate the alphanumeric display to see in exact words what the fault is, what they're looking at, what the diagnostic is. The Vacon 20X, if you went out to it in the middle of the field, you would need to either have a printed manual with you to interpret the messages and the codes, or you would have to have internet access and be able to look at it on an iPad or a phone or something, and that's just not convenient. So just FYI. The 100X has what are called thin film or plastic foil capacitors. They do not use electrolytic caps, so they are maintenance free. They don't dry out, they last longer. So you get a longer operating life out of the capacitors in the 100X. 100X is rated 3G vibration versus the 2G of the 20X. So, and we do actually offer IEC mounting plates to mount these to an IEC motor. We never made any NEMA mounting plates, but a customer could fabricate their own. So you could mount this drive to the pump motor directly, or you could mount it, of course, on any post or whatever out in the field. And it is rated for up to 60 degrees maximum. The 20X was rated to 50 degrees. So now with just those few features, hopefully you will understand the big price difference between the 100X and the 20X, the vibration rating, the ambient temperature rating, the type of capacitors, and the display. By the way, in both cases, the display, the 20X and the 100X, is magnetically mounted to the drive. You can simply remove it, and it will run, of course, without a keypad. So if for some reason somebody, didn't want to have the keypad out there, they could remove it, and you can reconnect it and disconnect it while the drive is live. There's no issues there. Also, of course, the software has the MPPT software in it. The 100 drive is available for solar applications for 60 horsepower up to 1,000. Why only 60 horsepower? Because you are to use the NEMA 4X drives up to 50 horsepower. So we have made the solar software available, the solar software license, I will talk more about that in a little bit, for the 60 horsepower and above in the standard 100, which is available in NEMA 1 and NEMA 12. The 100 family, like in the 100X, uses those really cool plastic foil capacitors for longer life and more durability. However, the 100 drives are rated for only 50 C ambient temperature, something to keep in mind. So as I'm not going to read the specs on here, but you can see that we do go up in the 500 volt up to 800 volt PV array up to 1,000 horsepower. In the 230 volt, we go up to 125. So that would be, yeah. So even though they show that technically you can get a 20 horsepower or 40 horsepower in, say, the 380 volt, I'm telling you, because I've already encountered this, they don't want to sell the solar license for the lower horsepowers in a NEMA 1, except with exceptions. So they want you to do the NEMA 4X drive. So how does it?
Lisa, this might be a good time to ask our first poll question and let you rest a second. How's that sound?
Yes, good idea. Let's do that. I completely forgot about that. Let's do that. Is that something, John, that you put on the screen?
Yeah, I just put it on the screen. They should see it now.
Perfect.
Which drive product lines can be used with a solar panel for a pump? And so we've got 5 choices. Hopefully you can pick more than one. And we have no results yet.
Uh-oh.
5% of the people voted. Come on, guys and gals.
Nobody's paying attention. It's boring.
We'll give them a little more time.
Okay.
Okay. Well, we've had 1/3 of the people vote so far.
Oh, okay.
Oh, now we're cranking it up. If you want to vote, you better hurry up because I'm getting ready to stop it. Okay. I will close the poll and share it with them. So can you see the results? Lisa, can you see the results or no?
Let's see. Can
Yeah,
I click?
90% of the people.
Everybody got it? Let's see. 90%, 40%, 10%.
So they didn't do as well. Why don't you give them the right answer?
Okay, so the products that can be done for solar pumping are the Vacon 20X, the Vacon 100X, and the Vacon 100. The Sun Drive isn't a product of ours, and the no Danfoss VLT drive is made for solar pumping. So we have no VLT drives. That isn't to say, because I have done an application, actually a very large one, using an FC202 with a PV array, but all of the solar software and functions were done externally in a separate MPPT software. So this was an integrator that had developed their own solar software, and so they just wanted a dumb inverter. What I'm sharing with you is a standalone inverters that have the solar software, which is key and critical for solar pumping, installed and included in the drive. There's no external solar software required. So that's the difference. All right, John, so I guess, can you put, how do I get
it off? Your next slide, see if it goes back to your slide.
Let's see if it works here. It's not working, hold on. Nope, so let's try, should I hit stop and then restart screen sharing?
There you go, perfect. Now we see
Okay.
slide 13.
You can see it?
Yep, you're good to go.
Okay, why is my face there? I'm gonna turn my face off. Okay, all right. So a solar pump drive, how does it work? Some other brands may use what are called under voltage regulators. And this could be in the drive, or it could be external to the drive in a PLC or something that's then sending a reference to the drive. But basically, if you're just using a simple under voltage regulator for solar pumping, the drive will simply reduce the pump speed once the DC voltage hits a minimum level. So as your PV array starts to produce less voltage, the pump will just simply get slower and slower and slower. And that occurs when the solar panels obviously are not producing enough energy in order to keep the speed set point. And then in those cases with those under voltage regulator type drives, the solar panels usually are working at a non-optimal voltage. So those are very poor solar inverters. The most advanced controllers for solar, the drive will receive the maximum power from the solar panels by keeping the DC voltage produced by the panel at the optimum point. And that's why we call it max power point, is the MPP. Let's see if I can get this. Uh-oh. How do I get it to advance? My buttons aren't working anymore. I'm changing slides. What did I do? How do I get it to?
You may have to close it and reopen it. Your mouse is working.
Yeah, but it's working on my, that's on my laptop, not on my keyboard. My keyboard, there we go. All right, it came back to life. Okay, so how does it work? So you've got a PV panel, a PV array, I guess I should say, of panels, where you end up with a graph there showing its current versus its voltage as it receives radiance from the sun. And you can see the various curves that could occur there based upon how much irradiance you are receiving from the sun. And then you can see how that translates into your speed with your inverter output, your volts per hertz on your inverter output. And you can see they nicely did grabbed that grab those points off the solar panel energy into the best inverter output possible for your water pumping. So you can see there you're now between, say, your minimum and your maximum, say 200 volts to 400 volts. This is in a 230 volt inverter, and how that would affect your pump curve. So, and this is done by maximum power point tracking. So if you were to look at this differently as to a simple controller that wasn't doing these calculations and this MPPT algorithms, as though as the irradiance is lower, you would not have the same amount of flow out of the pump, because it would not know how to calculate and produce the higher volts per hertz that you would get using our software algorithm. So the MPPT 4 for 4 algorithms is a dedicated application software for solar pumping that we have created or produced with an optimized algorithm for the 20X and the 100X. It implements 4 concurrent algorithms that happen all at the same time. It has a feed-forward controller to follow the radiation variations. It has a correction controller to compensate for any temperature variations. It has a oscillation damping regulator to catch back the panels entering into the current source mode. And then it has a local maximum bypass logic to skip what's called a false maximum point in case of partial irradiation. So it's not really important that you understand every single one of those and how it works. I just want to share with you that we have these algorithms in there. They're all working concurrently, and the ultimate result, like any other algorithm, is determine the optimum output to the motor. And then, of course, the motor will drive the pump. So here's just one example of one of the algorithms, which is to skip the false maximum. So we have a specific logic which is unique to our software to bypass what's called the local maxima, which is not the true maximum power point, and it's caused by panel degradation, partial irradiation, etc. And our software and algorithm allows or enables the drive to skip this point and reach an overall maximum. So it just shows you here in the graph how your power. So you can see there the blue line, for example, on the left, the blue line is the power irradiation from the solar panels. And then the red is the output power generated from the solar panel. So the IV is the rating from the solar panel. And then when you look at the simulation, you can see that there are some local maximum points that are considered false. They're not the true maximum points. Our algorithm will determine which is the maximum power point, which is that max 2. The max 1 and max 3 are ignored, and it uses that information to give your maximum output to the motor. So you end up with the end result is you get a generated a higher output power. Increases the amount of pumped water that you get, extends the pump working time during the day. And I'm not going to go into details of this one, this last point here about other regulators that call themselves MPPT, but they're really under voltage controller with corrections. So these are just graphs that they had created based upon testing some other brands of solar pump inverters and their software. And it was just to show how they responded. And the summary is that our algorithm is top-notch. It's superior to many that are out there. Here is a way to understand how a big impact your investment in an MPPT control can increase the efficiency of the system by double digits. So if you're encountering a sales situation where you're competing against another solar inverter that appears to be substantially lower cost than yours, this is how or than ours, I should say, the 100X, for example. This is how we have that discussion with the customer, that the installation or initial investment from the purchase of the inverter is only 5% of the total lifetime cost of that operating system. 10% is due to maintenance. 10% of your total lifetime cost is in maintenance, which is service and maintenance, and that is typically of the pump and the motor itself, not of the drive. And then 85% of your lifetime cost of a solar pumping system is your energy consumption. So a superior solar drive will save or will produce more with the energy it receives from your solar panels, is a way to think of it. You'll get more for your money over time. So something to think about. This one is just to show you an existing solar pump project that was done with the 100X. You can see in the graphic there, the 100X drive is mounted next to some additional outdoor panels that had additional things for the farm. And don't be put off by seeing those two huge other outdoor boxes that were created with all kinds of other components, and that looks like so much. Those components were specific to, you know, other things that are not necessarily for the solar pumping. There was other things that were going on at this installation that needed meters and controls, etc. So this one was just another one that was done in Spain, and it was just with the standard 100 that was put in a box. So, okay. How to order. So the solar pump applications are available from the factory. So you can order the drives, the 100 and the 100X, with a plus code. Which is A1181. That is actually the application software code, A1181. The 20X has a different software code, A1163. The solar pump application can also be downloaded into the 100 and the 100X when you get a license code. The license code is created using our license generating key called Vacon key, and it is no cost. And by the way, the Vacon 20 cold plate, in case for those of you who didn't know, the Vacon 20 cold plate is actually the drive that's inside the Vacon 20X. So in theory, we could do solar pumping with the Vacon 20 cold plate drive, but I'm not talking about that one because nobody would ever use it. So the same rules are valid in solar panel supply as in AC supply with drives as far as output filters. So, so I've had installations where the customer has put DVDT or sine filters on the output. Those same rules, those same guidelines still apply even if you're using the inverter in a solar powered application. So if you have installations where the motor winding can be weak or is not inverter duty, you would want a sine filter on there. Or if you have very long cables between the inverter and the pump motor, you may need an output filter as well. Now that second one doesn't apply so much with the NEMA 4X drives because you can mount it right next to the motor out in the field. It's more applicable to the larger 100 drives where you may have it mounted in a cabinet that's in a e-house or is, you know, in some shelter away from the pump motor. Now, dimensioning the 20X, when you go to choose your drive, you can follow the same dimensioning and sizing that you would do for any standard inverter application. You size it based upon the motor current rating. And then what we've shown in the manual here is your maximum recommended PV array power for that particular size drive. So this will help. It's interesting because I've had people inquire with me where they haven't even purchased their solar array yet. And they want me to tell them, you know, what size solar array they need to buy. And I have to explain to them that they need to start from the pumping end and work their way backwards. They need to determine how much water or how much flow or how much pump power they want first, and then you kind of work your way backwards. If they already have an existing solar panel, that's actually even easier because we can calculate based upon the amount of PV array power they have, which size drive and motor it will power. So just an FYI, you know, it's hard for us to tell somebody, you know, what size array they need to build. They really need to figure that out themselves. We can give them, you know, basic information like this for them to make their educated decisions. So when you're dimensioning, or I don't know if dimensioning is the right word, when you're speccing out using the 20X for a solar application, you need to be aware that there are additional components that are needed. DC fuses to protect the drive. That's just like anything. If you were powering these drives with any DC supply, same as when you're powering from the AC supply, you need to put fusing in there to protect the drive. So you have to put DC fuses in there. You should put in a protection diode and a diode, and a DC switch. And the protection diode is to prevent something occurring, especially if you've got AC power connected, from going back into the PV array. And those components right there, you see the DC fuses, the DC switch, and the protection diode are the components that we talked about that you would have in a separate box. But they're not heat producing, so you don't have to worry about cooling them or anything like that. So this chart actually shows you which 20X drives are available for the solar software. There are a couple of sizes, the MU2 in the 3-phase 380 and the 3-phase 230. That frame size is not available for solar. And I think it had something to do with the sizing of the capacitors in there. Because remember, this is a standard product that we are applying to a solar application using solar software. And but you can get the MU2 frame size, which is up to 2 horsepower in the single phase rated units. Those have the larger capacitor that can handle the solar. Okay, so you're covered then all the way up to 5 horsepower with a 3, 4, and 5 horsepower with a 230 volt 3 horsepower, 230 volt 3-phase drive, and then the single phase 230 volt drive, you're up to 2 horsepower. And then in 460 volt, we can offer you 5, 7.5, and 10 horsepower. On the 100X, same thing here. We can give you the maximum recommended PV array based upon, you know, if you already know what your array PV power is, PV array power is, we can tell you, you know, which drive matches up with that. But you should still also verify what your motor current requirements are for the application. And same thing with the 100X. You will need to have a DC switch, DC fuses, and a protection diode added externally to the drive as part of your installation, site installation. The 100X ratings go all the way up to 50 horsepower, 20 horsepower, and 230 volt. You can get the solar software. Now, I have also created myself, so that's technically the end of the presentation from Global, but I've added some notes and some things here myself. This is the spreadsheet that I created, that I just pasted here for reference. based upon questions that I've had from customers and applications I've worked on. The biggest question I get all the time when they're sizing their PV array, because they need to produce voltage that's in our drive's voltage range. The biggest question I always get is, well, what's the minimum voltage that your drive will continue to operate at? And what's the minimum voltage before the drive goes to sleep? So what the drive does when it's in a solar application, if eventually the solar power goes away, the drive will actually fall asleep, and it'll wait until the voltage from the PV array or an AC supply hits a minimum voltage in the DC bus, and it will wake up. So what I put here, for example, is the minimum DC link voltage for the drive to actually modulate an output to the motor, albeit it could be very slow, or what the wake-up voltage is. So you can see here in a 480 volt drive, which is up to 800 volts DC, that's the max link voltage for the MPPT software to work, is 436. So your real operating range is between 436 and 800 volts. Okay, then we have a maximum input hardware limit. In this case, I'm just looking at the first column, and then you guys can look at the other columns later, is 900 volts. So it can handle up to 900 volts coming from the PV array, but you're not getting anything extra out of the drive at 900 volts, just FYI. So then the other big question is, what about the open circuit voltage, what's called the VOC, the open circuit voltage maximum instantaneous voltage when the drive will trip is 911. So when you have a solar array that's producing and it's not connected to our drive, and then you all of a sudden connect it with that DC switch to the drive, it can only handle up to 911 volts. So if your solar panel array has an open circuit voltage greater than 911 volts, the drive will trip. So in those cases, if your spec of your PV array is greater than that for the VOC, you should have to put a load resistor or something in there that will pull that voltage down to the 911 or less when it's connected to the drive. So we can help you with that if you have that situation. So those are just my notes. I have this spreadsheet. I can share it with you if anybody wants, but I put it here for you. You can look at it there. We talked about the power blending already, so I'm not going to go over those again. But what I do want to go over again, because in the global software, it was not detailed enough on how to buy these products in the US. So first thing you need to know is the solar software has no cost adder. There is no adder for the solar software. So if you want to buy the Vacon 20X, you have to buy it as a configured drive. And this is an example. So you can see there the A1163 is the software for it. The QGLC, by the way, is just a Imperial Units conduit plate. LS60 means have the drive pre-programmed for 60 hertz motors. LSUS just means for settings for the US, meaning typical 460 volt motors, etc. And then HMTXs just come with the keypad. The drive will be manufactured in our plant in Italy. The software will be installed. It will be labeled as such with the A1163, but your lead time is typically 4 to 6 weeks, which could be longer during summer and Christmas shutdowns that Italy does, and of course virus shutdowns. So ordering the 20X, you have to order it. We do not stock it in the US. You have to order it from the factory. It does have a long lead time. Now, if you want to buy the 100X, again, the software has no cost adder. So you can take, it's standard pricing in theory. And I'll explain that. But to buy the Vacon 100X for solar, you have two choices. The first choice is just like the 20X. You order the drive configured for solar. And in this case, you can see there A1181, and then the rest of the options. And I should have marked plus FBIE as optional. That is if you want Ethernet communications included. If you're not doing any Ethernet communications to the drive, you don't need the FBIE. And then again, you have to wait the lead time to get the drive. So that one is the first choice. The second choice is you order the standard US configuration out of stock. You buy a programming cable. And for example, you would buy, here's an example of the part number right out of the catalog, right out of the book, nothing special, 100 3L0031-4-X-R02. Or in the case of a NEMA 1, NEMA 12, Vacon 100, you can see the part number there. When you receive the drive, and hopefully it would come out of stock, in particular the NEMA 4X drives, we do keep a tremendous amount of stock, so chances are it will be in stock. When you receive the drive, you need to send an email to that email address, give them the serial number of the drive, and request a license code for the solar software. They will send you the license code and the solar software in an email, and then you would use the Vacon Live Loader software and that cable you had to buy, and you install the solar software to the drive yourself. You download it into, you basically are flashing the firmware to install the solar software yourself. Unfortunately, there you will have to disconnect the AMC filter manually. That requires removing the cover off the drive, removing a screw, and then putting the cover back on. So if you're not comfortable with doing that, then you'll have to buy it, wait the lead time. So this is a roundabout way to take a drive from stock and not have to wait the lead time, but you got to do a little work to get it to work with the solar. And wanted to cover one other area, and that is we do have another way to work with solar panels, and that is with another product called the NXP DC-DC converter. And I'm only going to take a minute here, but I just wanted to show you that we do have another product, a higher end product that also uses the same algorithm. And if you look here, you can see this is what we would consider a drive system off of solar panels. What we've been talking about all along has been one drive, one motor, driving one pump, and with a PV array. We do have solutions if you have multiple PV arrays, you want multiple drives driving other things on a complete system that could be connected to the utility, could be connected to energy storage, such as a battery. I just wanted to show you that you can use the NXP DC-DC converter with solar arrays to produce a DC bus that's used in a common DC bus system. So if you look at this graphic, you see the utility on the left contributing to the DC bus. You can see the DC bus is powering a bunch of motors, and that's converting that DC back to AC. And then we have a solar array, a couple of solar arrays there, two of them, that using our DC-DC converter, we're taking those solar arrays and contributing to that DC bus. And then you can see we can take off that DC bus and create a microgrid. That's where it says microgrid 400 volts. And we can also add energy storage. So I just wanted you to be aware we can do complete systems, DC bus systems that include solar panels as well as the solar pumping. But the solar pumping was the focus. So that is it. That covers what I needed and wanted to cover. I don't remember, John, I think we had one more survey question. Otherwise, yeah, otherwise we can just open it up to questions in general, but if you want to ask the survey question, I'd be curious to see what they picked up.
Yeah, we can go ahead and we'll ask that. And I thought you did a great job on the presentation. You answered all the questions that had come in during your presentation.
Oh, okay.
You did good. You get an A+ on that.
Yay, thank you. I didn't see any questions, so it was lucky then. But yeah.
Guillermo threw a couple questions in there, but I thought you covered them nicely.
Oh, okay. And I can talk with Guillermo afterwards if he had more questions. I don't know if Nate had any questions, but
Nate was just bragging on what a great job you were doing.
oh my God. Thank you. Okay, so if there's no other questions, we can do the survey question if you want, or we can skip it. It doesn't matter.
I've got the survey running right now as we're talking.
Okay, good. So what I was going to say was, please, attendees, funnel all of your inquiries and questions directly through the L3 group or through Bob Darby. And then I would be more than happy to support and help Bob Darby navigate our system to get what he needs or get questions answered. This way, everything is funneled through him. And that would be greatly appreciated.
Super. Lisa, thank you very much. That was awesome.
Oh, you're welcome. Happy to help.
All right, everybody have a safe weekend.
Yes, please do. And let's see what we got here. Yes, but with safety measures, no, never. Don't even think about it. I'm going to assume that
we did get one question. Somebody asked approximate cost. So the
well,
cost.
there is no cost adder for the solar software. So it's your standard drive cost. There is no cost adder. So if you were to look in your price book for a Vacon 100X drive, and you bought the standard drive, the solar software is no adder. Now, when we do the complete configuration with breaking it out into order from Italy, it comes out about the same cost as the standard drive. There's just a few minor differences, but basically, it's a standard drive cost. No adder.
Fantastic.
Yeah.
All right. Thanks, Lisa.
Okay.
Have a great weekend.
Thank you, everybody. You have a great weekend as well. I'm looking forward to it, and have a great rest of the day.
Thanks. Bye.
Thank you. Okay. Bye-bye. I don't know.